Bucket Detective is actually it's actually a pretty performance intensive game. And that's not because we're like pushing the bounds of technology or anything like, The Witcher 3. Unfortunately, it's actually, I mean, it's a result of a lot of things, but there are some kind of newbie mistakes that were made primarily by me that I'll share with you guys just to sort of educate you if you've never made a game of this size before, like I hadn't. Because I had done The Static Speaks My Name, and it was a very small game. That was the biggest game I'd done, but it was very small. So I didn't really have a lot of the issues that we ended up running into on this one. One of the biggest ones is that we didn't use what are called texture atlases. Now, you see in the game there's a lot of wood, and there's a lot of like brass. There's a certain amount of brass, and there's also like that white of the wall paint. Those are probably our most common elements. The wood especially is in basically like, I don't know, 50% of the objects in the game. And what I did is we, like, instead of having, the way you're supposed to do it is you create this thing called a texture atlas. And a texture atlas is like, imagine a 4K image that's split into like 4 parts. So there's like 4 quadrants. And in each of those quadrants, you've got a different texture. So like you'd have wood, you'd have brass, you'd have the white of the wall, and you'd have maybe the green carpet. And when you're applying textures to your models, you're not actually making a different texture or material for every object, but you're pulling from that same texture. That way you only have to load this one texture in to the memory and create a material for it, and then put that on the objects. You get this one texture to do a lot of work. So that the wood that you see on a bookcase and a wardrobe and the wall and a picture frame, it's all the same wood as far as the computer is concerned. We did not do that. I did not know about that. There's a different texture for the stairs and for the walls and for the wardrobe, even though they use a lot of the same sort of wood texture. We have different materials created for them. And I should explain, I'm using kind of textures and materials interchangeably here, but a material is basically what Unity calls the thing that you apply to a model. So a material is actually made up of textures. Textures are, in the case of Unity, texture is an image file, a 2D image file, which would be like, some color information. And then you would also have another texture, which would be a normal map, which is an image which tells the game how to render light and shadow. Like you see, like they kind of also used to be known as like bump maps. It's what gives like the little bumps or cracks or something that you'll see on a wall or on a concrete floor or something. Anyway, so a material is made up of textures, and so I'm using them interchangeably, but if you have a lot of textures, you probably have a lot of materials in Unity. So anyway, we have just too many materials and textures, which kind of ends up chugging the game, sort of making it more intensive than it needs to be. Ultimately, the game does run okay. I mean, we have on my friend's MacBook Air, we got the game running at 25 frames a second or something. So, and he said, he would never expect a first-person shooter to run on his Mac Air. So 25 frames a second is decent, but the game could have run a lot better. But that's just that's what happens when you make a game bigger than something you've made before, and you've got a small team, and you're kind of learning along the way. The other thing we did, I did, yes, most of these mistakes are my fault because my programmer is much more technically skilled than I am. But the other thing I did was there's a lot of objects in the game, and that's okay. But it basically matters how you categorize these things. So each book in the game that's in a bookshelf is a separate game object. And this is maybe like so technical that I don't know how relevant it'll be, but just to, whatever, if you want to learn this, you can. Each game is sort of categorized as a separate game object. The correct way to do it, the more efficient, optimized way of doing it, is to group all of those books into one giant game object. So you can still have them be separate from each other. They don't have to be like connected. Like, if you remember like games in like, the mid 90s where you'd have a bookcase that was really just like a block that had different like drawings that made the books look separate. You can still have the books be separate, but you want them to all be the same mesh or the same game object. That was something I wasn't really aware of. I wasn't aware that it was as big a problem as it was. So that's one thing we've got, because you basically have to. It's just more intensive for the processor to draw separate objects than if they were to be grouped together. And I remember hearing an interview with like one of the engine programmers for Fallout 4 or something. Some engines actually they build tools to where they can make the meshes individually, but then they can combine the meshes in the engine itself, so that the modelers don't have to actually worry about like modeling putting everything together. The engine kind of handles it. That would be super cool. I don't, as far as I know, Unity doesn't have that tool. Or I think I spoke with my programmer like a week or so ago about it, and he said, yeah, I mean, maybe we could do that, but the fear of it breaking something at this point, especially since we release tomorrow, is sort of outweighed the performance bump that we get. And the other thing is that we didn't end up using baked lighting. So basically, I actually wrote about this on my website, a bit more of a detailed thing. So if this is like too brief talking about baked lighting, if you're really into learning about that, you can go check out my website, thewhalehusband.com. I think it's a January 2017 like blog post. But basically, there's two ways of thinking about, two broad ways of doing lighting: real-time lighting and baked lighting. Real-time lighting, as you can imagine, happens in real time. If you have an object move, it will cast a shadow which moves. And baked lighting is something that happens before the game is even shipped. The lighting is baked and sort of like cooked into the environment. Because it's not happening in real time, it's obviously much more performance friendly. There's a variety of reasons why we ended up going with real-time lighting instead of baked lighting. The biggest one, honestly, is that we needed to ship this game. And baked lighting, at least how it is in Unity right now, as of Unity 5.5, is very finicky, and it requires, like, every time you want to move a light and see how something looks, you have to rebake, which baking just one floor of the game takes like 10 minutes. So it was going to be a process of like a week or two to get us to have, at least that's what we estimated, to have the game's lighting look how it already looked with real-time lighting. So we kind of had to make the call that like, look, we just don't have the time to do this. So what we ended up doing is having a setting where you could toggle on and off real-time shadows. So you can, if it's off, there's maybe 7 actual real-time shadows in the game, and if it's on, all the lights or most of the lights cast real-time shadows. So that was sort of our workaround. But yeah, so overall, I think it's not great performance. It's not a game that is gonna, I think we calculated like, what was it? We used my programmer's laptop as the benchmark, and like his was like exactly at the 50% mark of Steam users, and the game runs well on his. So we figured at least 50% are going to have the game run really well, and below that, they may have to turn off some quality settings in order to get the game running decently. But to be fair, by running well, I mean the game for him, it ran at 60 FPS. And I believe, I can't remember fully now, but I think he even had real-time shadows turned on and all that stuff. So we could have done better, but we could have done a lot worse. And that's what making a game is. It's a process of learning so that you can do things better next time and have a whole new set of things that you can mess up the next time around.